中国 J-35战斗机的历史、现状与未来概述。1、发展背景与起源。中国的 J-35战斗机是由沈阳飞机工业集团 SAC 研发的一款多用途隐形战斗机，其研发起源于 FC-31项目，最初旨在开发一种出口型隐形战斗机。FC-31的首飞于2012年10月31日进行，标志着中国在战斗机研发领域的重大进展。2021年10月29日 ，J-35的首次飞行进一步推动了其向海军化方向的转变，显示出中国航空技术的不断壮大。2、设计与技术。J-35战斗机分为陆基型 J-35A 和舰载型 J-35B， 前者主要用于中国人民解放军空军 PLAF， 后者则专为中国人民解放军海军航空兵 PLANAF 设计，支持弹射起飞。J-35的设计强调隐形特性，采用低可探测性设计和先进的航电系统，包括主动电子扫描阵列 AESA、雷达和红外搜索与跟踪系统 IRST， 提升了其在现代战场上的生存能力。重要设计特点。隐形设计。 J-35采用了低雷达反射截面设计，并使用雷达吸收材料，增强了隐形性能。航电系统配备了 KLJ-7A 雷达，具有强大的目标探测与追踪能力。动力系统初期搭载的 Klimov RD-93 发动机已逐步被更高效的 WS-13E 和 WS-21 发动机取代，后者能提供更高的推力和更好的燃油经济性。3、重要时间节点。2012年 FC-31 原型机首飞，开启隐形战斗机研发之路。2016年 FC-31 第二原型机飞行，进行多项技术改进。2021年10月29日 J-35 舰载型原型机完成首飞，增加了折叠机翼和弹射起飞装置。2023年9月26日 J-35A 陆基型首次飞行，展示其独特的设计。2024年11月12日 J-35A 在珠海航展上进行首次公开飞行表演，标志着该型号的正式亮相。4、战略意义与未来展望。 J-35 的问世使中国成为继美国之后拥有2种隐形战斗机的国家，显著提升了中国在全球军事航空领域的竞争力。分析人士认为， J-35 在战斗性能上有可能超越现有的4代战斗机，如 F-15 和 F-16， 但其对 F-22 和 F-35 的竞争力将取决于数量、飞行员素质以及雷达和传感器的技术水平。出口潜力。 J-35 的出口潜力也备受关注，尤其是在一些无法负担美国战斗机的国家中。中国与巴基斯坦的合作关系日益紧密，巴基斯坦已开始对 FC-31 及其更先进的 J-35 型号表现出兴趣，未来可能成为 J-35 的潜在用户。5、总结。 J-35 战斗机的发展历程展现了中国在隐形技术和战斗机制造领域的快速进步。从初期的 FC-31 原型机到如今的多种作战变体， J-35 不仅增强了中国空军的战斗能力，也为未来的国际军售市场提供了新的选择。随着技术的不断迭代与升级， J-35 的未来可期。通过对 J-35 的深入分析，可以预测其将在未来的空战中扮演重要角色，成为中国空军和海军航空兵的重要力量。
Counterintuitive information. 1. Indigenous development versus copying allegations. The J-35 has been often compared to the F-35 and accused of being a copy. However, several experts argue that while the J-35 incorporates features found in the F-35, it is primarily a product of indigenous design efforts. This notion contrasts with the widespread belief that China primarily relies on espionage to develop its aircraft capabilities. 2. Market positioning. While the J-35 is positioned as a competitor to advanced Western fighters, its design and development history reveal a focus on catering to markets that may not afford top-tier American aircraft. This strategy may seem counterintuitive, given the general perception that China's military ambitions are aligned with direct confrontation rather than market competition. 3. Simultaneous development of naval and land variants. The development of both naval J-35 and land-based J-35A variants in parallel is not typical for such advanced fighter projects. This dual approach deviates from conventional military engineering practices where one variant often dominates the design process, suggesting a unique strategic flexibility within China's military aviation sector. 4. Operational role clarity. The J-35's role as both a naval and air force asset complicates its strategic classification. Analysts typically expect specialization in modern military aviation, but the J-35's design allows it to fulfill multiple roles, effectively challenging traditional notions of fighter jet utility. 5. Performance claims versus realities. There are claims that the J-35 could match or exceed the performance of existing fourth-generation fighters like the F-15 and F-16. However, the actual combat effectiveness against fifth-generation fighters like the F-22 and F-35 will depend significantly on pilot training, operational strategy, and technological integration rather than just the aircraft's specifications. 6. International collaboration. The close collaboration between China and countries like Pakistan in developing variants of the J-35 offers a counterintuitive angle on military competition. Rather than viewing China solely as a competitor, this relationship illustrates how China's aircraft development can include strategic partnerships, broadening its influence in global military aviation. 7. Technological evolution. The evolution from the FC-31 to the J-35 reflects a remarkable acceleration in China's technological capabilities. Critics often see China as lagging behind Western nations in military technology. However, the rapid advancements demonstrated by the J-35 suggest a more nuanced reality where China is quickly catching up and even innovating in certain aspects. 8. Environmental considerations. The focus on stealth and reduced radar cross-section in the J-35's design emphasizes a technological arms race primarily centered around detection capabilities. This focus on stealth can be counterintuitive in a world increasingly aware of the environmental impacts of military operations where fuel efficiency and emissions are becoming essential considerations. 9. Public perception versus military reality. The public unveiling of the J-35A at the Zhuhai Airshow contrasts with the actual operational readiness of the aircraft. The timing of such public displays often leads to a perception of immediate capability, which may not align with the actual timeline for full operational deployment. 10. Engine development timeline. The transition from older engines like the Klimov RD-93 to the indigenous WS-13 and WS-21 engines reflects a strategic pivot towards self-reliance in military technology. This shift may seem counterintuitive given the historical reliance on foreign technology, but shows a long-term vision for sustainable military aviation capabilities. These counterintuitive aspects highlight the complex interplay between technological development, strategic military objectives, and global market dynamics in the context of the J-35 fighter jet's evolution and deployment. The J-35 jet, an advanced stealth fighter developed by China's Shenyang Aircraft Corporation, represents a significant milestone in China's military aerospace capabilities. While many reports focus on the J-35 specifications, design, and the timeline of its development, certain critical aspects often receive insufficient attention. Here are some important content areas that are likely overlooked, along with their significance. 1. Strategic implications in the context of global military dynamics. The J-35's development signifies China's growing ambition in the realm of military aviation, particularly in the context of its strategic competition with the United States. The fact that China is now the only country apart from the US to possess two types of fifth-generation stealth fighters, the J-20 and J-35, implies a robust capability to project power both regionally and globally. Analysts often discuss the J-35's potential to rival fourth-generation fighters like the F-15 and F-16, but the implications of its existence on the international arms market are equally vital. Countries unable to procure American fighter jets due to cost or geopolitical constraints may turn to the J-35 as a viable alternative. This could shift the balance of military power in various regions, especially in Asia, where countries like Pakistan have already expressed interest in acquiring the J-35. The strategic partnerships that could arise from these sales may enhance China's influence in areas traditionally aligned with Western powers. 2. Technological advancements in stealth features. While the J-35's stealth capabilities are frequently mentioned, the specific technological advancements that contribute to its low observability often go underexplored. The design employs advanced features such as serpentine inlets to conceal engine components from radar detection, sawtooth edges, and radar-absorbent materials. The J-35's ability to potentially evade detection by L-band and Ku-band radars could offer it a tactical advantage in modern combat scenarios where stealth plays a critical role in survivability and mission success. Moreover, the integration of advanced avionics, including the active electronically scanned array AESA radar and infrared search and track IRST systems, positions the J-35 to effectively counter advanced adversaries. The implications of these technologies extend beyond the aircraft itself. They represent a leap in Chinese aerospace engineering that could influence future military aircraft developments, including potential sixth-generation fighters. 3. Evolution of naval warfare capabilities. The J-35's carrier-capable variant is particularly significant given the increasing importance of naval power in modern conflicts. As China expands its naval capabilities, the introduction of the J-35 to its aircraft carriers will enhance the People's Liberation Army Navy's planned ability to project air power far beyond its shores. The capability for catapult launches and its design for operations on both catapult-equipped and ski-jump carriers like the Liaoning and Shandong marks a considerable enhancement in planned operational flexibility. The strategic role of the J-35 in naval warfare could potentially alter the maritime balance in the South China Sea and beyond, where air superiority is crucial for achieving broader military objectives. The J-35 could serve as a deterrent against regional adversaries, amplifying China's military posture in contested areas. 4. Impact on international military collaborations. The collaboration between China and countries like Pakistan in the development and potential acquisition of the J-35 highlights the growing military ties that could reshape regional alliances. The interest from Pakistan in both the J-31 and J-35 indicates a shift towards greater reliance on Chinese military technology, which could lead to joint development programs and training initiatives. This burgeoning relationship also raises questions about future conflicts and the potential for technological transfer. If Pakistan were to adopt the J-35, it could lead to an arms race in South Asia, prompting India and other neighboring countries to accelerate their own fighter jet programs, such as the HAL-AMCA. The geopolitical ramifications of such developments deserve greater scrutiny, as they could lead to increased instability in the region. 5. Economic considerations and export potential. The economic implications of the J-35's development are significant, yet often overshadowed by its military capabilities. The potential for the J-35 to be marketed as a cost-effective alternative to Western fighters could open new markets for China in regions seeking to modernize their air forces but constrained by budgetary limitations. This could provide China with substantial economic benefits and enable it to establish a foothold in the global arms market. Furthermore, the development of the J-35 could stimulate domestic industries within China, fostering innovation and advancements in aerospace technologies. The economic impact extends beyond military applications. It may enhance China's overall technological landscape, benefiting various sectors in the long term. 6. Pilot training and operational readiness. The training of pilots to operate advanced fighter jets like the J-35 is a critical factor that is often overlooked. The effectiveness of any new aircraft depends not only on its technical specifications but also on the proficiency of the pilots operating it. China is likely investing in extensive training programs to ensure that its pilots can leverage the advanced capabilities of the J-35 effectively. The implications of pilot training extend to the overall readiness of the Chinese Air Force and Navy. As the J-35 becomes operational, the ability to integrate these new capabilities into existing air defense and offensive strategies will be crucial. The focus on pilot training and operational integration may have long-lasting effects on the PLA's operational effectiveness in future conflicts. Conclusion. The J-35 represents a transformative element in China's military aviation landscape. While discussions often center on its design and specifications, the broader implications of its development, ranging from strategic military dynamics and technological advancements to economic impacts and international collaborations, are equally critical. As global military paradigms shift, understanding these nuanced aspects will be essential for comprehending the future trajectory of military power in Asia and beyond. 4 key points for in-depth analysis of the China J-35 jet: history, present, and future. 1. Evolution from FC-31 to J-35, historical context and development. The journey of the J-35 fighter jet begins with its predecessor, the FC-31 project launched by the Shenyang Aircraft Corporation SAC. The FC-31 was initially intended as an export model for stealth technology designed to compete against Western fighters like the F-35. The first prototype of FC-31 made its maiden flight on October 31, 2012, showcasing China's ambition to develop a fifth-generation fighter. The evolution of FC-31 into the J-35 reflects significant advances in stealth technology, avionics, and design suitable for naval operations, including the integration of a catapult launch bar and folding wings for carrier operations. The J-35 was specifically designed to fulfill roles for both the People's Liberation Army Air Force (PLAF) and the People's Liberation Army Naval Air Force (PLANAF). The first flight of the J-35 took place on October 29, 2021, marking a pivotal moment in China's military aviation history as it transitioned from a land-based to a carrier-capable stealth fighter. This evolution reflects not only technical advancements but also strategic military objectives aimed at enhancing China's aerial combat capabilities in contested environments. 2. Design and technological innovations. The J-35's design incorporates several cutting-edge technologies that enhance its operational capabilities. Key features include stealth characteristics. The aircraft is designed with a low radar cross-section (RCS) achieved through its shape materials and internal weapon bays. The use of serpentine inlets helps to obscure engine blades from radar detection, while the overall design minimizes radar reflections. Avionics and sensor systems. The J-35 is equipped with advanced avionics, including an active electronically scanned array AESA radar and an infrared search and track IRST system. These systems enhance situational awareness and target acquisition capabilities, allowing the aircraft to engage in both air-to-air and air-to-ground combat effectively. Engine developments. The jet is powered by an evolved version of the WS-13 engine known as the WS-21, which offers improved thrust and efficiency. Future variants are expected to incorporate even more powerful engines such as the WS-19, enhancing the aircraft's performance and operational range. These innovations position the J-35 as a formidable contender against existing fourth-generation fighters and potentially against fifth-generation aircraft like the F-22 and F-35, depending on the operational context and the quality of the pilots. 3. Strategic implications and regional dynamics. The introduction of the J-35 has significant implications for regional security and military balance. With the capability to operate from aircraft carriers, The J-35 strengthens China's naval power projection in the Asia-Pacific region and beyond. This development is particularly relevant given ongoing tensions in areas such as the South China Sea and Taiwan Strait where air superiority is critical. The J-35's development also prompts responses from regional adversaries. Countries like India and Japan are investing in their own fifth-generation fighter programs such as the HAL AMCA and Mitsubishi FX to counterbalance China's advancements. Additionally, the J-35's potential export markets may include nations unable to afford Western fighters, which could shift the balance of power in favor of China in various regions. Furthermore, the strategic partnership between China and Pakistan, highlighted by ongoing discussions regarding Pakistan's interest in acquiring the J-35, underscores the geopolitical ramifications of the aircraft's entry into service. This collaboration could enhance the operational capabilities of Pakistan's Air Force and create a new axis of military cooperation in South Asia. 4. Future outlook, potential for upgrades and export opportunities. Looking ahead, the J-35 is poised for further advancements and potential upgrades. As technology evolves, future iterations could incorporate enhanced stealth features, advanced avionics, and more powerful engines, ensuring that the J-35 remains competitive in a rapidly changing aerial warfare landscape. The anticipated introduction of the WS-19 engine capable of supercruise could significantly enhance its performance and operational flexibility. In terms of export potential, the J-35 is likely to attract interest from countries seeking advanced military aircraft without the political constraints associated with purchasing from Western manufacturers. Its design and capabilities could appeal to nations with emerging air forces looking to bolster their aerial combat capabilities affordably. The success of the J-35 in international markets could further solidify China's position as a leading arms exporter, competing directly with established players in the military aviation sector. This could reshape global defense procurement trends, especially among nations seeking alternatives to US-made fighters. Conclusion: the China J-35 jet encapsulates a significant leap in military aviation technology, reflecting China's growing capabilities in stealth and aerial combat. Its historical evolution, cutting-edge design, strategic implications for regional security, and promising future in both operational upgrades and export opportunities make it a critical subject for analysis and discussion. As the geopolitical landscape evolves, so too will the role of the J-35 in shaping the future of air warfare and military alliances. 1. F-22 Raptor, United States. The F-22 Raptor is a fifth-generation single-seat twin-engine all-weather stealth tactical fighter aircraft developed for the United States Air Force. The F-22 was designed primarily as an air superiority fighter but also has ground attack, electronic warfare, and signal intelligence capabilities. Developed by Lockheed Martin in partnership with Boeing, the F-22 made its first flight in 1997 and was introduced into service in 2005. Its advanced avionics, supercruise capability, and stealth technology allow it to evade detection while engaging multiple targets. The F-22 represents a significant leap in aerial combat capabilities, showcasing the evolution of air power in the 21st century. 2. Chengdu J-20, China. The Chengdu J-20 is China's first stealth fighter jet. Developed by Chengdu Aircraft Industry Group, it made its maiden flight in January 2011 and was officially adopted by the People's Liberation Army Air Force in March 2017. The J-20 is designed for air superiority and ground attack missions, featuring advanced stealth characteristics and supercruise capability. Its design includes canard wings and a long fuselage, providing it with a significant operational range. The J-20 aims to enhance China's combat capabilities and is considered a direct competitor to the F-22 and F-35. 3. Mikoyan MiG-35, Russia. The Mikoyan MiG-35 is a multi-role fighter aircraft developed by the Mikoyan Design Bureau. It is an advanced version of the MiG-29 and incorporates modern avionics, sensors, and weaponry. The MiG-35 made its first flight in 2007 and has been touted for its agility, advanced sensors, and capability to conduct a range of air-to-air and air-to-ground missions. The aircraft features a thrust vectoring engine which enhances its maneuverability in combat situations. The MiG-35 is aimed at both domestic and export markets, positioning itself against Western and other advanced fighter aircraft. Future outlook, predictions for the Shenyang J-35 jet. As the Shenyang J-35 jet emerges as a significant player in the realm of fifth-generation stealth fighters, its future prospects can be examined through various lenses including technological advancements, strategic implications, and potential market dynamics. Here are several predictions for the trajectory of the J-35 in the coming years. 1. Technological advancements. Enhanced stealth features, as global military technology continues to evolve. The J-35 is likely to undergo further enhancements in its stealth capabilities. This may include the refinement of radar-absorbent materials and the integration of advanced electronic warfare systems to counter enemy detection methods. Next-generation avionics. The J-35 will likely see upgrades in its avionics suite, potentially integrating more sophisticated active electronically scanned array AESA radar systems, enhanced sensor fusion capabilities, and artificial intelligence AI for improved situational awareness and targeting efficacy. Engine developments. The anticipated introduction of the Guizhou WS-19 engine, designed to provide higher thrust and improved fuel efficiency, could enhance the J-35's operational range and performance. This advancement may also enable supercruise capabilities, allowing the jet to maintain supersonic speeds without afterburners, thereby conserving fuel and reducing thermal signatures. 2. Strategic implications. Regional power dynamics. The introduction of the J-35 is set to alter the balance of air power in the Asia-Pacific region. As China enhances its aerial capabilities with the J-35, neighboring countries such as India and Japan are likely to accelerate their own military modernization efforts, potentially leading to an arms race in advanced fighter jets. Increased naval operations. With the J-35 specifically designed for carrier operations, its deployment on China's new aircraft carriers such as the Type 003 will bolster the People's Liberation Army Navy plan capabilities. This could expand China's maritime reach and assertiveness in contested areas like the South China Sea. Potential export opportunities. The J-35 may position itself as a viable alternative for countries unable to procure American-made fighters like the F-35. Nations seeking advanced yet more affordable combat aircraft may turn to the J-35, particularly in regions like South Asia and the Middle East. Strategic partnerships such as with Pakistan may facilitate such exports. 3. Operational integration. Joint operations. The J-35 is expected to enhance the PLA's capability for joint operations, particularly in integrated air and missile defense scenarios. Its compatibility with other Chinese military assets will likely create a more cohesive and lethal operational environment for the PLA. Training and development. As the J-35 enters service, there will be a significant focus on pilot training and maintenance personnel development. The PLA will likely invest heavily in simulation technology and training programs to ensure that pilots can maximize the aircraft's capabilities. 4. Challenges and countermeasures. Counter-stealth technologies. As the J-35 becomes operational, adversaries will invest in technologies to counter its stealth features. This includes advanced radar systems and electronic warfare capabilities designed to detect and engage stealth aircraft. The J-35's design will need continuous iteration to maintain its tactical advantages. Geopolitical tensions. The deployment of the J-35 could exacerbate tensions between China and other global powers, particularly the United States. This may lead to increased military presence and exercises in the Asia-Pacific by the U.S. and its allies, thereby creating a more volatile security environment. 5. Market dynamics. Competitive landscape. the J-35 will face competition not only from established aircraft like the F-35 but also from emerging platforms developed by countries like India and Russia, e.g. HAL AMCA and Sukhoi Su-75. The J-35's success in the export market will depend on its cost-effectiveness, performance, and the geopolitical relationships China can foster. Technological partnerships. China may seek partnerships with other nations to co-develop or co-produce variants of the J-35 which could enhance its technological base while also solidifying alliances with partner countries. This strategy could also mitigate the risk of sanctions from Western nations. Conclusion. The future of the Shenyang J-35 jet is poised to be dynamic and multifaceted, shaped by advancements in technology, shifts in regional power dynamics, and the ever-evolving landscape of international military aviation. As China continues to develop and refine the J-35, its implications for both regional and global security will be significant, influencing military strategies and international relations for years to come.